So in this video, I'm going to talk about fossil fuels, and this is actually in a different chapter of your book, so you can look this up if you would like to. It's in the chapter, it's a chapter on energy and specifically dealing with fossil fuels. So when we talk about fossil fuels, like what are they? And you'll remember that we talked about the carbon cycle extensively and how autotrophs, which are photosynthetic, can capture carbon from the atmosphere and incorporate them into organic molecules. So when we talk about fossil fuels, these are organic molecules. And so what does that mean? That means that they are composed of hydrocarbons primarily. So when we talk about hydrocarbons, this means that they have hydrogen and carbon atoms in them. And so when we talk about fossil fuels, we also talk about the fact that these are not renewable sources of energy. And the reason why they're non-renewable is that it takes millions of years for the formation of these fossil fuels, and we are using the fossil fuels faster than they can be replenished. So it's not a sustainable, renewable source of energy. So it is non-renewable energy, and it is not sustainable. So when we talk about creating a sustainable lifestyle, it would involve using renewable energy sources that are able to replenish themselves or are not even used up. So for example, the solar energy from the sun is not something that we're using and it's depleting it. It is a constant source of energy. So when we talk about fossil fuels, we could talk about the types of fossil fuels. So for example, coal would be an example of a fossil fuel. So would oil, but you might have heard of areas where they are extracting fossil fuels from, say, for example, sand. So we have sand oil, and we also have a type of oil that is found in shale. So for example, in Canada, this is a very hard oil to extract because it is mixed in with other material. And so it's not like concentrated, like it's not like just oil, an oil field or a coal seam that you can easily access and get rid of the impurities. So it takes a little bit more work. So remember that idea that we talked about at the very beginning of this quarter, where we were talking about how the best is used first. So we use up the easiest to extract fossil fuel first, and now it's going to take a little bit more effort and a little bit more energy in order to extract the rest of it. So the best first principle was something that we talked about in this class. So if we look at the fossil fuels, these are actually the autotrophs. So for example, the zooplankton, the phytoplankton, autotrophs. And this has to do with the net primary productivity. And what does that mean? You'll remember that we talked about photosynthesis and how organisms are able to capture carbon from the atmosphere. So they capture carbon from the atmosphere and then they put it into organic molecules. And in order for fossil fuels to actually form, these organic molecules have to be in a great abundance. And so if you think about like a swamp, for example, that has a high primary productivity, we have a lot of organic material. And then, interestingly, it has to be buried. So it actually has to be buried in order for anaerobic decomposition. So that is the decomposition of the organic material using anaerobic bacteria that don't use oxygen. And so it decomposes it, but it doesn't release the CO2 into the atmosphere. So the carbon gets stored in this concentrated form. So net primary productivity it's related to that. and then you bury the material. And this could be like a sea coming in and sediment being deposited on top. So changes in sea levels affected this. So you bury the material, and then you have anaerobic decomposition. So it starts to break it down. And so then that produces this concentrated form of energy that we have been able to take advantage of, and we've been able to extract, and it has completely changed the way that we live on the planet. So if you think about sources of renewable energy might have been in the past trees, but however, in order for it to be renewable, you would have to make sure that your forests are growing as fast as you're cutting them down to use as biofuels. So when we use wood, we need to make sure that it is, or we needed to in the past, make sure that we were also planting forests so that we could have a renewable supply of that. So we didn't want to cut down all the trees for firewood. Sometimes that happened in different places, and then people had to move to different areas because they depleted that resource, and so it wasn't sustainable. So when we talk about fossil fuels in the 1800s, it's only been since the 1800s that we have been able to use this resource. And what it has caused, or what it has allowed us to do, is to have a society that is very energy intensive. So we use a lot of energy to drive to work, right? We use a lot of energy to power our electrical devices. We use a lot of energy to fly great distances. And so it's allowed this amazing thing to happen. However, we now realize that there is a cost to that. So one of the major costs is not the fact that we are going to be running out of fossil fuels. Eventually that will happen. And remember that they're going to be harder to extract, and it's going to be harder to get to them over time. But the major cost now is that we have built up, we have released all of this carbon that was underground. We have released it into our atmosphere. And so we are contributing to climate change, which is going to, again, dramatically change the way that we live. So it's going to dramatically change our climate, how we use water, for example, is going to dramatically change the way we do agriculture. And so it is very interesting period of time to be alive because of all of this change that is going to happen. And hopefully one of the things that we'll be able to do is figure out how to get that CO2 out of the atmosphere. Maybe we could put it into sinks. We can extract it from the atmosphere. Maybe we could use technology in a good way to do this. Maybe we could develop renewable sources of energy. We already have. And it isn't a given that our lifestyles are going to be dramatically worse with renewable energy. So there are a lot of people that think that if we decided to go to renewable, that our lifestyle is going to just be miserable. We're just going to go back to the cave era, right? But what if there is the possibility that renewable energy can make our lives better? And so that's what this section in renewable energy and sustainable biology is going to be about.